Welcome everyone, and now the next topic of the discussion is empirical and molecular formula. Now what is meant by the empirical formula? Empirical formula is the formula which shows the simplest whole number ratio of atoms present in a compound. So basically, empirical formula is the formula which shows the simplest chemical composition of a compound. It shows the simplest whole number ratio. For example, in case of glucose, the ratio between carbon, hydrogen and oxygen is 6 by 12 by 6. It can be simplified by dividing it with 6. So it will become 1 ratio 2 ratio 1. And this formula will be, according to this ratio, the formula will be CH2O. Now this CH2O is the formula that shows the simplest whole number ratio between the atoms which are present in the glucose. So it will be its empirical formula. Empirical formula of two or more than two compounds can also be same. For example, in case of acetic acid, which is CH3COOH, the ratio between carbon, hydrogen and oxygen is 2 ratio 4 ratio 2. When it will be simplified, it will also become 1 ratio 2 ratio 1, and its empirical formula will also be CH2O. The molecular formula or the actual formula of the glucose and acetic acid, they are different, but their empirical formula are same. Let us take another example, that is this one is the formula of lactic acid. The ratio between carbon, hydrogen and oxygen is 3 ratio 6 ratio 3. If it is simplified, it will become 1 ratio 2 ratio 1, and its empirical formula will also be CH2. Let's take another example, that is formaldehyde. So in case of formaldehyde, the ratio between carbon, hydrogen and oxygen is 1 ratio 2 ratio 1. So its empirical formula will also be CH2O. It means that two or more than two compounds of different molecular formula may have same empirical formula. This one is a very important MCQ. It is asked that which of the following has same empirical formula. A option will be glucose, B will be acetic acid, C will be lactic acid, and D will be all of these. So you must know that all of these compounds, they have same empirical formula, and it is CH2O. Now, what is molecular formula? Molecular formula is the formula which shows actual ratio Empirical formula shows simplest ratio between the atoms, but the molecular formula shows actual composition of a compound. It shows the actual ratio. Like in case of glucose, this one is its molecular formula. In case of acetic acid, its molecular formula. In case of lactic acid, its molecular formula will be C3H6O3. In case of formaldehyde, its molecular formula will be CH2O. In case of formaldehyde, the empirical and molecular formula are same. And in case of acetic acid, C2H4O2. That will be its molecular formula. So empirical formula shows simplest composition and the molecular formula shows actual composition of a compound. After giving these examples, let me tell you one thing very important, that all the ionic compounds, for example, if we have sodium chloride, NaCl is the formula unit of sodium chloride. It is not its molecular formula because sodium chloride is an ionic solid and it does not consist of molecules. So NaCl will be its formula unit. And this formula unit is actually the empirical formula of NaCl. So formula unit of every ionic compound is actually its empirical formula, which shows the simplest ratio between the ions. Similarly, another very important point about the empirical formula is that macromolecules, like one of the very common example of the macromolecules is silica. The silica having formula SiO2. This SiO2 is again, it's not its molecular formula. Because macromolecules, they consist of large number of atoms in three-dimensional region. So SiO2 is the simplified formula of the silica. It will be also called as its empirical formula. Finally, what I want to say is that the formula unit of every ionic compound is its empirical formula, and the formula written of every macromolecule is also its empirical formula. Now the most important thing is that how we can calculate these empirical and molecular formula. Let us first see that how many steps are involved in the calculation of the empirical formula. Then we will take an example and we will calculate the empirical and molecular formula. In calculation of empirical formula, there are total 4 steps. So first of all, keep in mind that how many steps are there in the calculation of empirical formula. There are 4 steps. The first step is to find percentage composition of a compound. If we want to calculate the empirical formula of any compound, the first step will be to calculate its percentage composition. The second one will be to calculate the number of gram atoms or moles. You must have an idea that gram, atom and mole are the same terms. But how this number of gram atoms or number of moles is calculated? It is calculated by dividing the percentage composition, percentage of every element with its atomic mass, or you may also say with its molar mass. So you will divide percentage of element with its atomic mass and you will get the number of gram atoms or number of moles. Now what is the third step? The third step is to calculate the simplest atomic ratio. How can we calculate the simplest atomic ratio? We will get some values of the moles and we will divide all the values of the moles with the smallest of those values and we will get the simplest atomic ratio. The fourth will be to convert simplest atomic ratio to whole number. The fourth step is not necessarily included in all the calculations. If the simplest atomic ratio is in fractions, then it becomes very important to convert it into the whole number. How can we convert it? That is again very important. How will it be converted? By the multiplication with a suitable number. We will multiply that fractional ratio with a suitable number to convert it into the whole number. So these are the four steps. Now let us take an example. Suppose that we are given some data that in a compound the percentage of carbon is 40.92%. The percentage of hydrogen is 4.58% and the percentage of oxygen is 54.5%. This one is the data which is given and the required is to find the empirical formula. Now there is no need to perform the first step because the percentage composition is already given, and this percentage composition, if it is an organic compound, it might have been calculated from the combustion analysis. We will start from the second step, and usually in the practicals, usually in the numericals, the percentage composition is already given. If the percentage composition is not given, we can calculate the percentage composition, as I have already given a lecture on how to calculate the percentage composition. So we will start from the second step, that is number of gram atoms. We will calculate number of gram atoms. Now let us first calculate the number of gram atoms of carbon, then hydrogen and then oxygen. The formula is to divide the percentage of every element with its atomic mass. The percentage of carbon is 40.92. So you will divide it with its molar mass or atomic mass, that is 12. The percentage of hydrogen is 4.58 and you will divide it by 1.008, that is the atomic mass of hydrogen. And third, oxygen 54.5 and we will divide it with 16. Here the atomic masses are taken, not the molecular masses, because we talk about the ratio of the atoms, not the ratio of the molecules. Now what will be their answers? You can calculate that 40.92 divided by 12, it should come out to be 3.41. Similarly, the hydrogen, when it will be calculated, it will be 4.54 and 54.5 divided by 16, it will also come out to be 3.41. Now these are actually the number of moles or number of gram atoms. 3.41 moles of carbon, 4.54 mole of hydrogen and 3.41 mole of oxygen. So the second step is over. Now the third step, find the simplest atomic ratio. And how can we find the simplest atomic ratio? The simplest way is to divide. Let's do it. Carbon, hydrogen and oxygen, the number of moles of carbon are 3.41, hydrogen 4.54 and oxygen 3.41. 3.41. You are to look at the smallest value among these. I think so that among these three values, the smallest value is 3.41, and all these values will be divided by the smallest value. So the smallest value is 3.41. We will divide every value with 3.41. It will be calculated and it will come out to be 1:1.33:1. Now this 1:1.33:1, that is the simplest atomic ratio. So how the simplest atomic ratio is calculated? By dividing all the values of the gram atoms with the smallest of those values. Now the third step is over, but you can see that the simplest atomic ratio, it is in the fractions, it is not in the whole number. So we will have to convert it to the whole number by multiplying with the suitable smallest number. If we multiply this ratio with 1, I think so there will be no difference. If we multiply this 1:1.33:1 with 2, it will become 2:2.66:2, but it will again remain 2.66 and it will be fractional again, so 2 is not the suitable number. Which one is the suitable number? That is 3. When we will multiply it with 3, we will get 3:3.99:3. And you know 3.99, that can be written as 4, so 3:4:3. This one is the final simplest whole number ratio. It was simplest ratio, but it was not in whole number. So the simplest whole number ratio is 3:4:3. Why it is important to convert it into the whole number? Because the atoms are a solid entity. Atom is a solid entity. It may be one atom, it may be two atom, it may be three atom, but there is no concept of the 1.5 atoms or 1.3 atoms. So it is necessary to convert this fractional ratio into the whole numbers. In this way, this one is the simplest atomic ratio, and according to this simplest atomic ratio, the empirical formula of this compound is C3H4O3. And this empirical formula is of basically ascorbic acid. Because that percentage composition at the start, that was given of the ascorbic acid. And ascorbic acid is another name of vitamin C. In this way, we have calculated the empirical formula of the ascorbic acid. Now let's move towards our next step, that is how to calculate the molecular formula. First of all, we must have an idea that what is the relationship between molecular formula and empirical formula. So molecular formula is equal to N into empirical formula. Where N is a simple integer. This is the relationship between molecular formula and empirical formula, and this relationship can be read as molecular formula is the integral multiple of empirical formula. Now this simple integer n is calculated by dividing the molecular mass or molecular formula mass with empirical formula mass. We have calculated the empirical formula of ascorbic acid. It is C3H4O3. So we can easily calculate the empirical formula mass as well. What will be its empirical formula mass? 12 into 3 plus 1 into 4 plus 16 into 3. So 12 into 3, that will be 36 plus 4, 40 plus 48. That will be 88 grams. So 88 grams per mole, that is basically the empirical formula mass of the ascorbic acid. Empirical formula mass is with us. We already know the empirical formula. Now what is the hindrance in the calculation of the molecular formula? The hindrance is actually this one, that the molecular mass is not given. Now molecular mass is determined by using different techniques. Like molecular mass can be determined by mass spectrometry. Even it can also be determined by using the vapor density method. So molecular mass, whenever you will be solving some numerical value in which the molecular formula is required, you will always be given this molecular mass. So molecular mass of ascorbic acid. Now what is the molecular mass of ascorbic acid? That is 176 grams per mole. It will be given to you people. And it is calculated by using different techniques. So molecular mass is 176 gram per mole. Now we can calculate N. Molecular mass is 176. Empirical formula mass is 88. And I think so when you will divide it, it will come out to be 2. So this N is equal to 2. Now what will be the molecular formula? I think so molecular formula is equal to N into empirical formula. Empirical formula is C3H4O3. So when you will multiply it, it will come out to be C6H8O6. This C6H8O6 is actually the molecular formula of the ascorbic acid. So first of all, we will calculate the empirical formula. Then the molecular mass is already calculated by using some technique, and when we will be solving the numerical, it will be given. After finding the empirical formula, we will find the value of N, and then we will multiply this value of N with the empirical formula, and we will get the molecular formula, which is the actual formula of a compound. So this was an example that how to calculate the empirical and molecular formula of any compound. Sometimes the MCQs are asked from a relation. Suppose we have written that molecular formula is equal to N into empirical formula. We can also write it as molecular formula over N is equal to empirical formula. We can also write it as empirical formula, molecular formula over empirical formula is equal to N. And what will be delta? That will be all of these. So the question will be, which of the following is a correct relation? So all of these are the correct relation. Basically these are rearranged forms of this relationship. In this way the MCQ can be asked. Then how many steps are there in the calculation of the empirical formula? 4 steps. It is an MCQ. Then empirical formula of which of the following compound is same? For example, CH. That is empirical formula of benzene, and that is empirical formula of ethine as well. So in alpha, that will be benzene, beta, ethine, Charlie, both A and B, and delta, ethene. CH is empirical formula of, so CH is empirical formula of both A and B. Benzene is C6H6, which is simplified to CH, and ethine is C2H2, which is also simplified to the CH. Now, in case of water, what is the value of N? N is the integer which connects the empirical formula and molecular formula with each other. You can see that water is a compound having same empirical and molecular formula. And for all those compounds that have same empirical and molecular formula, the value of N will be 1. So these are some important points, important MCQs that I have discussed with you people that can be asked from the empirical and molecular formula. The empirical formula of two different compounds can also be same. For example, let me give you another example. Suppose I say that empirical formula of a compound is CXHYOZ. This is empirical formula of the compound. What will be its molecular formula? I think so molecular formula will be CN into X, H N into Y, and O N into Z. Because every number which is written below the symbol of the element, it is multiplied with the N, so that will be its molecular formula. In this way, we can find the empirical and molecular formula. If two compounds have different molecular formula, their empirical formula can be same. Just like in two hands, there are 10 fingers. So the formula should be 2 hands, 10 fingers. But if there are 3 hands, 15 fingers. So in both cases, the ratio will be 1:5. Number of hands are different, number of fingers are different, but the ratio is same. Because the 5 fingers are there per hand. So that's why the empirical formula is same, but molecular formula in both cases, that is different. I hope so that the idea is clear and it was all about the topic of empirical and molecular formula. Thank you so much. Allah Hafiz.